Hello guys, in this video we are going to explore connected components, or rather count the number of connected components in a graph. It is different from the previous video or the other video on connected components because we are going to use an adjacency list representation of the graph this time around. This is the graph that we will be talking about. This has three connected components. In the first connected component we have vertices 0, 1 and 2. The second connected component has vertices 3 and 4, and the third connected component has vertex 5. We are going to now explore the code using the adjacency list representation. Let's begin writing the code. My file will be called as connected components 1. I begin by including iostream. I include another header file hash include list. This is for the list container that we will be using. I'm going to use the standard namespace here. In the main function, let's go ahead and let's make AL, which is the pointer to list integer. The container is the list container. It will be holding integer values and I'm making a pointer to it. And I'm going to, this is nothing but a dynamic array of lists. That's essentially the adjacency list. We're going to deal with 6 vertices. Let's verify. This is going to be, so the total number of vertices are 6 here. What we are going to do next is, let's code out the add edge function. I will pass the adjacency list to it. The vertices, if you look at the graph, I am going to connect vertices 0 and 1 and 0 and 2. There is no connection between 1 and 2. So 0 and 1 as well as 0 and 2. So remember, this is going to be an unweighted, undirected graph. This simply means that if there is an edge from 0 to 1, there also is an edge from 1 to 0. Let's code out add edge, and we are going to go ahead and connect 3 and 4, and that's about the representation. Let me write down the add edge function, which receives as a parameter the adjacency list representation. The first vertex called u, second vertex called v. So let's use the pushback function to push into u the vertex v, and because it's an undirected graph, u into v. We are going to keep a visited array, 6 vertices, and I'm going to initialize them all to false, meaning they are not visited. A variable count set to 0. Then I'm going to run a loop from I0 I is less than 6, and if I encountered a vertex which is false, that means it's not been visited, do a DFS and pass on the graph representation, the adjacency list representation, the source vertex which is I, and all the vertices which have been visited so far. Then I'm simply going to go ahead and display the count of connected components. Let's code out the DFS function. So I will simply go ahead and use the list of integer type, that's for the adjacency list representation, the source, and the boolean visited array. Let's set the source vertex as visited by setting visited as equals true. Let's look at the adjacent vertices to it. I'll be using an iterator here. Iterator is called IT. It has to be of list int type, and let me assign it the beginning. It goes till the end here, and I'm going to do an IT++. Now check the visited array. Remember, star IT gives me the vertex number. So if you have not visited the vertex so far, call the DFS pass it the adjacency list representation. Star IT happens to be the source, and first it contains the count of all the vertices, contains which all vertices we have covered so far. Otherwise it's going to be stuck in an infinite loop. Let's try to run it. Okay, compiled without errors. Let's run it. So it's giving us the answer as 3. There are total of 3 connected components. That's about it. Happy learning, guys. Be safe.